Hi students, today we're looking at limits in algebra. That is, we are going to find limits algebraically so we don't have to graph everything. Because I don't know about you, but that seems like a force to me. I'd also like to remind you that on your copy of this, you see things here. These are the Khan Academy assignments that it is expected that you can do after this video. All right, so looking at these, if you think about the connection that we made way back in like pre-algebra, one of the reasons that we graph things is to understand the shape of different algebraic functions. We can go backwards for that too. We can use algebra to understand what happens as far as limits. And what I mean by that is something called evaluating limits based on direct substitution. So as long as our graph behaves normally, we should be able to plug this number in and just kind of see what happens. So we've got negative, and I've got -3 squared. Please be careful here. That negative out front means that I have that extra negative there. If you throw this on a calculator, it will be incorrect unless you use the parentheses. -2 times -3, and then +2. So we're going to end up with negative, that's going to be +9, -2 times 3 is +6, +2 is going to be -1. If I were to graph this as x approached -3, we would also end up at -1. And at that point, we'd be done. All right, for number 16, well, let's take a look. When I plug -3 in, we get -3 plus 3. Be careful with my parentheses again. Squared plus 4 times -3, and then +3. And on top, we got 0. On the bottom, -9, +9. -12 is -3 plus 3 is, we have something weird going on here. We get 0 over 0 as an answer. And that's a little bit problematic for us. That's not something that we're comfortable with. We've never seen that before. This is something called an indeterminate form. We're going to basically see indeterminate forms of this nature in this class. The other one that we're going to look at is going to be infinity over infinity. But generally, when we see something like this and when we're dealing with this part of the year, it's just going to be 0 over 0. This always means the same thing. This means that this limit might exist. So if we're looking at something where the limit might exist, that means we might be able to do some work to make this limit actually show up. And the first thing that we're going to learn about doing is factoring. So if I were to rewrite this, and here I'm going to do x approaches -3, get a double negative there. X plus 3 is good on top. We can't really factor that. The bottom of this is a quadratic, and by golly, that looks factorable to me. There's also a hint, because this thing gave me 0 over 0, I'm guessing that x plus 3 has to be a factor. And in fact, it is. The other factor is going to be x plus 1. So if you thought you were done with factoring in Algebra 2, you're just beginning. I can reduce by x plus 3. And when I rewrite this, and by the way, do you notice that I'm rewriting the limit with this problem as well? That is really important for us to do in every step of the problem. If you have a limit, you have to rewrite it until you plug that number in. And we get 1 on top, and on the bottom we got x plus 1. That gives us 1 over -2. Interesting. Let's take a look at this graphically. And with the magic of technology, I have added a graph of this, and we can see that at -3, undefined. So we have a hole in this graph at this place where we took the limit. We can see that the limit does indeed exist. I was not smart enough to include the y-axis, but it would have a height of -0.5 there. I'm just going to get out of the way. And then finally, we're going to end up with the same issue. I'm betting, I'm not entirely sure, but I'm going to guess that when I plug these things in. So we're talking about 2 times 3/2 squared is 9/4. Minus 5 times 3/2 is going to be 15/2. plus 3. And on the bottom, I'm going to end up with 3 minus 3 is going to be 0. So let's just kind of see what happens here. 2 times 9 fourths is going to be 18 fourths. Minus 30 fourths, and finding some common denominators to get going here. Plus 12 fourths does indeed equal 0. So this also would give us 0 over 0, which might exist. And you might also guess that if I were to factor this guy, we'd end up with the limit as x approaches 3 over 2. And on top, we're going to have 2x minus 3, 2x minus 3, and that's going to end up with 1x and then minus 1. Those can reduce. When we plug this in, we end up getting that limit is equal to 3 halves minus 1, which is a half. One of the cool things here is that we have limits that we can now, instead of having to graph, deal with this algebraically. So we can do some factoring, and one of the nice things in limits of factoring is that you're probably going to be able to factor based on the numbers that they give you and based on what ends up showing up here. The fact that we got 0 over 0 means that something probably will cancel out. I can't guarantee that will always be the case, but that might be the case. All right, the last thing from here is this lovely link, which unfortunately is not a live link because Jamboard doesn't allow you to do that. But I made it a bit.ly so you can copy and paste that or type it in not too terribly in order to get to some problems to check your understanding. All of the answers are there, and if you need some help in class time, that's what that really is going to be for, to kind of go through those things.